Let's talk about what is density first. Also, we'll watch a video. Okay, when the word density comes in front of you, what can you make out of it? What do you think density is? Now, density is made from a word dense. Density is made from a word dense. Okay, dense can be called closely or tightly packed. Dense means closely or tightly packed. Like if you want me to use this word dense in a sentence, I would say that Mumbai is a dense city, or Mumbai is a densely populated city. So now you have a visual, you can say, idea about what dense means. Okay, I'll give you more example, more you can say relevant example. The Mumbai local trains are densely packed in the rush hours, right? In the rush hours, Mumbai local trains are densely packed with people. There are so many people that there is no space. So dense also means less space, less space for everyone, less space for each and everyone, less space, more people. Okay, but we are not going to talk about people over here. So in the place of people, I'm just I will just remove this word people, and in the place of people, if I write more particles, is that fine? Because we are talking about substances, na, in physics. We are not talking about cities or people. We are talking about substances. So dense substances means less space and more particles. Closely or tightly packed particles. Now you have just studied about kinetic theory of matter in the previous chapter, and you know that every matter, every substance is made up of particles. If everything is made up of particles, right, and these particles have spaces between them, that is intermolecular spaces, and these particles attract each other with intermolecular forces of attraction. These we know from the kinetic theory of matter. So density is one more, you can say, aspect of the study of these particles. The particles can be closely or tightly packed, as in solids, or they can be loosely packed, as in liquids and gases. Okay, so let's first take a model. Take a model. Um, okay, let me draw one space for you and replicate it with similar spaces. Okay, and let me draw two spaces for you. So we have two spaces in front of us. You have to tell me which one is dense and which one is not dense. Okay, you have to tell yourself basically. So in the first space, the molecules are there, but they are just dispersed here and there. Okay, in the second space, the molecules are like this. There are some spaces between the molecules, but relatively, the molecules are tightly packed. Don't you see that? So I'm not drawing the full space, I'm not completing the whole thing. I'm just making a few molecules so that you understand the concept. Okay. Okay, so this is like how the whole space will be filled. The whole space will be filled like this with all these molecules. Okay, and here the molecules are spread here and there. So let me just write the molecules or the particles of substance or matter are spread throughout, or you can say spread far away from each other. And the particles here are not spread, the particles are densely packed. Okay, so now you can now visualize the, you can say, the actual meaning of the word density in both the cases. See, density is there, okay, denseness is there, but it is different in both the cases. Here the denseness is less because the particles are spread far away, and here the denseness is more. Now you must be wondering that why am I talking about denseness or tightly or closely or loosely packed particles? Because that's not how your teacher taught you. Yes, mostly teachers directly go to the definition and SI units and formula for density. But I want you to first visualize what is density. I want you to visualize what is density. Okay, so this is basically what density is. Here, denseness is less. Here, the denseness is more. In the other words, I can say that here density is less, and here density is more. Okay, less particle in the same space means less density. More particles in the same space, that means more density. So out of solid, liquids and gases, which one has the greater density? Can you tell me now? Out of solid, liquids and gases, which one has greater density? Out of solids, liquids and gases, solids have the greatest density because in the same space, if you take equal amount or equal volume of solid, liquid and gases, solids in the same volume will have the maximum number of particles tightly packed. That means the denseness of particles in a given volume of solid will be very high as compared to the denseness of particles of liquids and gases. That means solids, they have higher density. Now you understand one thing? Okay, but I'm going to take this topic a little more ahead and make it more challenging for you. Okay, one question I have for all of you. So I have two bags. I have two bags. In one bag, I have 1 kg of cotton. In other bag, I have 1 kg of iron. Okay, I will not tell you the shape of the bag. Okay, what you need to do in your notebooks right now, you need to draw the shapes of the bag in which there is 1 kg of cotton and 1 kg of iron. Okay, so basically what you're trying to do is you're trying to estimate the size of the bag in which I can stuff these things. The size of the bag in which I can put 1 kg of cotton versus the size of the bag in which I can put 1 kg of iron. So basically we are going to have a competition between these two, 1 kg of cotton and 1 kg of iron. So your time starts now. Pause the video and draw the size of the bags which could contain 1 kg cotton and 1 kg iron respectively on the either side. Okay, your time starts now. Pause the video and do it. Okay, I hope you're done. So, I will draw the size of the bags or the containers or the, you can say, spaces which could contain these two materials. Okay, relatively. Of course, not exact, but relatively. So, 1 kg cotton would be this much, and 1 kg iron would be this much. So these are the size of the bags which could hold these things. Okay, there is a huge difference. No problem. We'll go to that. We'll get to that. Okay. Next question. So this is, you can say, size of the bag. Now, comparison on the basis of size of the bag. Okay. Now, what I want to name this characteristic which we have just listed over here as volume. Size of the bag means volume. Volume means space occupied. Space occupied. Which substance occupies how much space? That is its volume. Okay, so here it's very very clear that iron, 1 kg of iron occupies less space, and 1 kg of cotton occupies more space. So 1 kg of iron has less volume, 1 kg of cotton has more volume. Okay, that is clear. The second thing which I want you to tell me, okay, I want you to tell me which out of these two is more heavy. Remember, 1 kg of cotton is more heavy or 1 kg of iron is more heavy. Please pause your video and write down. You cannot draw heavy, of course, but write down beneath these two figures which one is more heavy. 1 kg of cotton is more heavy or 1 kg of iron is more heavy. So you can write more heavy and less heavy wherever you feel like. Okay, think a little bit and then write. Okay, so I think you have written something. Now let's say which one is more heavier. Okay, 1 kg cotton and 1 kg iron, none of them is more heavier. They have the same weight same weight. They both have same weight. 1 kg cotton and 1 kg iron, they both have same weight. They both are 1 kg after all. If you happen to put both of them on a beam balance, they both would weigh 1 kg. The beam balance would be balanced. Okay, beam balance देखा है तुम लोगों ने? The person who sells vegetables on the street has got a beam balance in his hand. That's where you can find a beam balance. Okay, most of the shops which sells grocery or vegetables, they have electronic weighing machines, so we don't see beam balance in our day-to-day life anymore. But the street vegetable vendors have got beam balance till date. Okay, so they put the weights, iron weights, in one of the pan, and the substance or the you can say vegetables or fruits, whatever you're buying, in the other pan. And when the beam both the pans balances, when the beam is horizontal, that means the weight which is the iron weight which is put in one of the pan is the weight of the food article or whatever you are buying uh, in the other pan. Okay, so if you happen to put beam balance, if you happen to put 1 kg cotton and 1 kg iron in beam balance and check the weight, you would find that beam balance is horizontal. It is balancing. That means they both have same weight. None of them is heavier. So my question earlier, which is heavier, is absolutely wrong. It is you can't ask this question, right? Which is heavier? No, you can't ask this question. You can't answer this question. None of them is heavier because both have the same weight. Okay, so here I am actually comparing their mass. Now you would ask me, sir, what is the difference between mass and weight? Okay, so weight is basically the gravitational force acting on any body, and mass is the amount of matter contained in the body. So this is the definition of physics. Okay, but since we have not studied the difference between mass and weight till now, so I will consider mass and weight to be the same thing. Okay, so if you ask me, sir, what is my weight? Okay, so you can measure your weight on a, you can say, the weighing scale. Okay, and you can consider that that's your mass also. So for now, mass and weight are the same thing. Okay, don't get confused. Okay, so we have been comparing uh, 1 kg cotton and 1 kg iron. We found their volume, we found their mass or weight. Now we are going to I'm going to ask you another question, the third question. Please think and answer this question. I want you to compare their denseness or density. Let's call it density. Which has more density? Okay, so that's my next question to you. What I'm trying to do is I'm not reading the chapter for you, but I'm clearing your concepts. So if you are able to answer all these questions, that means you understand density very well, right? Okay. So the next question is in front of you. Which has more density? Compare the density of 1 kg of cotton and 1 kg of iron. You now know both occupy how much volume, both weigh how much, what is their weight. You have compared their volume, that is the space occupied by them. You have compared their weight or mass. Now you have to find or compare their density. You have to tell me which is more denser. So pause the video, think, and write your answer in your notebook. Great. So I think you all have got the answer. Now let's see whether you have got the correct answer or not. So the question was, which has more density? Now this is 1 kg of cotton. This is 1 kg of cotton and this is 1 kg of iron. Both have same weight. But this weight is made up of what? This mass is made up of what? This mass is made up of particles. Right? Without particle, there could be no mass, because mass is the amount of matter contained in the body. So there is matter in this cotton as well as there is matter in this iron, and that matter makes up its mass or its weight. Without matter, there could not be any mass or weight. So we understand that there must be some particles. Okay, now cotton has more volume, iron has less volume. You should be able to now very well answer that in which of the two, cotton or iron, in which of the two the particles are tightly packed. See, both have 1 kg weight, both have the same mass. Okay, you have the volume in front of you by common sense. Okay, now you have to tell me which one has tightly packed particles. So you are right if you are saying iron. In ions, the particles are tightly packed because there is no space. Space occupied is very, very less. The volume is very, very less. So particles in ions are tightly packed, as you can see over here. Very less spaces. And the particles of cotton, there are so many particles. But as you can see, they are not tightly packed. There are a lot of spaces between the particles of cotton. So particles are not tightly packed. Okay. Okay. Now it is very easy to tell which is dense. Tell me which is dense now. If you have written iron, 1 kg iron is more dense, then you are correct. Here the density is more. Here the density is less. So now the concept of density in your mind should be very, very clear. Density hota kya hai? So density is the ratio of mass per unit volume. Now I'm giving you the formula for density, which the textbook has explained directly. Density is nothing but mass upon volume. Density is nothing but mass per unit volume, mass upon volume. Okay, so this density tells you what does the density tells you? Density tells you that how tightly or how closely the particles of a matter are packed. Are they more tightly packed or less tightly packed? If more tightly packed, then the density will be high. Then the ratio of mass per unit volume will be high. See, as you can see in the case of iron, mass upon volume. If I check the ratio of mass upon volume of iron, the mass in case of iron and cotton is the same. Okay. But what about the volume? Here the volume is less. Here the volume is more. See, in this case, both have same masses. Both have same masses. But what about the volume? If you check the volume of iron, iron has less volume. If you check the volume of cotton, cotton has more volume. That means if you check the ratio separately and if you have good knowledge of mathematics, you can easily answer this question. If you check this ratio and if you check this ratio, in this ratio, the denominator is bigger. The numerator is same in both the ratios, but in this ratio, the denominator is bigger. In this ratio, the denominator is smaller. The ratio in which numerator is same, but the denominator is bigger is a smaller ratio. The value of that ratio is smaller. So the value of this particular ratio which is in front of us is smaller. That means the density is less. Why? Because the density is mass upon volume. And if the ratio, the value of mass upon volume is less, then the density will also be less. Here, the value of this particular ratio is more because the denominator is less. In any function, if the denominator is less and if the numerator is same as any other ratio, the value of that ratio will increase. That means density will increase. You understand? Now I have cleared all the concepts related to density and I have also given its formula. Now let me talk about the SI unit of density. Okay, so density, as I told you, is mass per unit volume. Now let me give you the units in which these quantities are measured. So mass is measured in kilograms. Mass is measured in kilograms. Volume is measured in meter cube. So the SI unit of density. SI unit, if you don't know what is SI unit, I'll tell you. S means standard, I means international. Standard international unit of density is kilogram per meter cube, kilogram upon meter cube, which could be written as kg m raised to minus 3. Right? We are using the laws of exponents and we are bringing this meter cube in the numerator and making its power negative, kg per meter cube. Okay, it is said as kg per meter cube. Remember this. The SI unit of density is kg per meter cube, kilogram per meter cube. Okay. Okay, so this is just the SI unit. There is one more unit which is known as CGS unit. Let us convert SI unit into CGS unit. Okay, so kilogram upon meter cube. Okay, now what is the CGS unit? CGS is centimeter gram second, which is a smaller unit. Okay, so can you tell me what is the CGS unit of mass? The CGS unit of mass is grams. And what is the CGS unit of volume? It is centimeter cube. Okay, so we have to convert kg into grams and meter cube into centimeter cube. How to convert kilogram into gram? We will multiply it by 1000. How to convert meter cube into centimeter cube? Now see, 1 meter is 100 centimeter. 1 meter is 100 centimeter. So 1 meter cube will be equal to 100 cube centimeter cube, which is 1000000 centimeter cube. Okay, so this will be multiplied by 10 lakh. 1 with 6 zeros in front of it. Okay, so if we multiply 1000 in the numerator and 10 lakh in the denominator, we get our unit in terms of, you can say, uh, gram per centimeter cube. Okay, that's the CGS unit. CGS unit is gram per centimeter cube. But what we are trying to do is we are trying to find the relationship between kg per meter cube and gram per centimeter cube. Okay, so let's cut these three zeros with these three zeros. So what you get is, uh, so here you will get 1 upon 1000 gram per centimeter cube. Let me write it in a simple way. Okay, so what did I do? I converted kg into grams and meter cube into centimeter cube. And in the process, when I multiplied kg by 1000, it became gram. When I multiplied meter cube with 10 lakh, it became centimeter cube. And these zeros also got cut. So I got 1 upon 1000 over here. So we have a relationship. What is the relationship? 1 kg per meter cube is equal to 1 upon 1000 gram per centimeter cube, or 1000 kg per meter cube is equal to 1 gram per centimeter cube. So this is nothing but the relationship between the SI unit and CGS unit of density. And this is extremely important. This will be useful from now up to class 12th. The whole concept of density with the SI unit and everything, the conversion of SI unit and everything. Okay, 1 gram per centimeter cube is 1000 kg per meter cube. So I'll give you one more relation, and this has to be remembered by you thoroughly. If you want to convert, if you want to convert kg per meter cube into gram per centimeter cube, what would you do? If you want to convert kg per meter cube into gram per centimeter cube, you would divide by 1000. And if you want to convert gram per centimeter cube into kg per meter cube, what would you do? You will multiply by 1000. Okay, so this is basically the SI unit, the formulae, the concept of density. Everything I have covered over here. I want you to take notes. So if you have not taken any notes, please note down everything, because it is not explained in this manner in your textbook. Okay. Now, before going ahead, I would want all of you to pay attention over here. Here, we have density of some substances uh, in gram per centimeter cube and kilogram per meter cube. Cork. You know cork? Corks are used for closing glass bottles, wine bottles, vinegar bottles. Okay. Cork has a density of 0.25 gram per centimeter cube or 250 kg per meter cube. Then the density of wood, the density of ice. If you ask me if you have to remember all this, no need to remember, but at least have an idea. Aluminium, zinc. See, the density is increasing. So metals generally have more density. Gold has the highest density in metals, 19.3 gram per centimeter cube or 19,300 kg per meter cube. Liquid. Alcohol has a density of 0.78 or 78 gram per centimeter cube or 780 kg per meter cube. Water has a density of 1 at 4 degrees Celsius. 1 means 1 gram per centimeter cube or 1000 kg per meter cube. Okay, I am also coming to one more interesting point after this. See the density of milk, very, very close to water. Glycerine, okay. Mercury is a liquid metal with the highest density. Mercury is such a metal on which iron also floats. So mercury is a liquid. If you put a coin inside it, it will not sink because mercury is a liquid with a very great density. It is a liquid metal basically, right? Okay. Let me now give you one more, you can say, idea about density. What do you mean by this statement? We have to write the meaning of the statement. Density of water is 1 gram per centimeter cube. What does it mean? It means, please note this down, it means that 1 gram of water occupies a space of 1 centimeter cube. 1 gram of water occupies a space of 1 centimeter cube. Okay. Next, density of water is 1000 kg per meter cube. What does it mean? It means that 1000 kg of water occupies a space of 1 meter cube. Okay, so this is how you can understand or visualize the meaning of density. Density simply tells you that how much weight of a substance occupies how much space. Okay, if in a given space more weight of a substance is stored, that means it has more density. If a given weight of substance occupies more volume, that means it has less density. Okay, so just you can say meaning of the statement that density of a substance is this. Okay, so let's see one video.
This is the example we left at in the previous video. If we drop a piece of balsa wood and a metal pin of the same mass into the water, what will happen? Will both of them float or will both of them sink? Or one stays afloat and one sinks? Just by intuition, we can say that the wooden block will float and the metal pin will sink. But if they're of the same mass, why does that happen? Shouldn't both float because of the buoyant force? This happens because of the difference in their densities. But what's density? Look at these two parking lots of the same size. One has 3 cars and the other has many cars. Which one is more dense? This one, correct? Yes. Now look at these two forests. Which one is more dense with trees? Clearly, it's this one. So in the same given amount of space, if there are more things, we say that it's denser. Density is simply the measure of how compact the mass in a substance or object is. If we have to go by its scientific definition, we would say that it's mass per unit volume. In short, it tells us how much mass exists in a given volume. The unit of density is kilogram per meter cubed. Mass is in kilograms and volume in meter cubed. Coming back to our example, why did the wood float and the pin sink? The wood floated on water because the density of the wood is lesser than the density of water. Hence, the upthrust of water on the wood is greater than the weight of the wood. Hence, it floated. But the density of a metal pin is more than the density of water. Though it looks tiny, there's more mass per unit volume within it as compared to water. Hence, the upthrust of water on the pin is less than the weight of the pin. So what can we conclude? If the density of an object is lesser than the density of the liquid, then it will float. And if the density of an object is more than the density of the liquid, then it will sink. We'll understand the Archimedes principle in the next video.
Okay, great. So I think the concept of density is very clear now with all of you. So just take notes in this class. Okay. So why do some substances float and why do some substances sink? In order to understand flotation and sinking in more detail, we must understand the concept of relative density. So let me give you a brief idea about relative density. Okay. What is density of water at 4 degrees Celsius? Do you remember? Density of water at 4 degrees Celsius, as we have seen in the table previously in the same chapter, is equal to 1000 kilogram per meter cube or 1 gram per centimeter cube. This is the density of water at 4 degrees Celsius. So you must be thinking, if we want to find about relative density, why are we studying the density of water? Why are we writing the density of water at all? Because relative density of any substance, let me write the whole thing, relative density of any substance, of any substance is equal to density of that substance, density of that substance, okay, upon density of water. That is the formula for relative density of any substance. And what does relative density tell you? Relative density will tell you whether a substance will sink in water or float in water. Okay, let me write that also. Relative density tells us whether a substance will sink or float in water. But how does relative density tells us that? Let us understand with an example. Okay. Now, first, for finding relative density of any substance, you should always remember that the unit of the density of any substance, whether it is kg per meter cube or gram per centimeter cube, whether you take the unit of density of any substance as kg per meter cube or gram per centimeter cube, the density of water should also be the same, that is kg per meter cube or gram per centimeter cube. So if you take the density of a substance in kg per meter cube, the density of water has also to be taken in the unit of kg per meter cube. Always remember that. If you are taking the density of a substance in gram per centimeter cube, okay, if you are taking the density of any substance in gram per centimeter cube, then take the density of water also in gram per centimeter cube. So always remember the numerator and denominator will always have same unit of density, whether it is SI unit, that is kg per meter cube, or CGS unit. Okay, let's take an example. Let's find relative density of wood. Okay, relative density of wood. What is relative density of wood? Density of wood upon density of water. Now let's find what is the density of wood. From the table, we already have a table. Yes, so in this table, the density of wood is 0.68 gram per centimeter cube or 680 kg per meter cube. Any one you can take. Okay, uh, I will show both of them. Okay, 0.68 gram per centimeter cube or 680 kg per meter cube. Okay, let's first take in kg per meter cube. 680 kg per meter cube. That's the density of wood upon density of water. Now, density of water has also to be taken in kg per meter cube because we have taken density of wood in kg per meter cube. So, density of water is how much? 1000 kg per meter cube. Now, this 0 cuts with this 0. Kg per meter cube both gets cut, and 68 divided by 100 we get, which is 0.68. What is the unit of relative density? It has got no units. Okay, so one more thing you must remember here is that relative density has no units. It's a number. It is only a number. It has got no units. Okay, let me also show you how to find relative density when we take the density of wood in gram per centimeter cube. Does not make any difference. So relative density of wood is equal to density of wood. Let's now take it in gram per centimeter cube, 0.68 gram per centimeter cube. That's what we saw in the table upon density of water, but also in gram per centimeter cube, 1 gram per centimeter cube. Okay, so this cuts right away and we get again 0.68. So it does not matter whether you take the density of the substance whose relative density has to be found out and density of water in kg per meter cube, that is SI unit, or gram per centimeter cube. But if you put them in the formula of relative density, you will find the same answer. The answer of relative density does not change. And one more important thing which we understood about relative density is that it has no units. It is only a number. So how does it tell you about whether a substance will sink or float? I will tell you. But after a couple of more examples, I will tell you whether a substance will sink or float in water. Let me take one more example for you. Let me take example of iron. Okay, iron. What is the relative density? Sorry, what is the density of iron? 7.8 or 7,800. Okay, now we'll take only in a single unit so that we can find its relative density fast. Let's find it. Okay, so relative density of iron is equal to density of iron in kg per meter cube. Let's take 7,800 kg per meter cube upon density of water in kg per meter cube, 1000 kg per meter cube. Okay, this will cut, 0 0 will cut, one more 0 will cut, 78 upon 10. 10 is 7.8 only. Okay, only a number, nothing else. So relative density of iron is 7.8. Okay, now let's find the relative density of water itself. What is the density of water? 1000 kg per meter cube. Okay, upon density of water, 1000 kg per meter cube. Everything gets cut, and what you get? 1. Okay, now we have got relative density of wood, which is 0.68, relative density of iron, which is 7.8, and relative density of water, 1. Okay, so the relation of sinking and floating objects with their relative densities. is given as over here. Okay, let me write it. An object will float in water if the relative density of object is smaller than 1. If relative density of object is smaller than 1, it will float. What is 1? 1 is the relative density of water. So if any object has a relative density less than that of water, it will float. And an object will sink in water if relative density of object is greater than 1. If relative density of object is greater than 1, what will happen? It will sink in water. Okay, so now we can understand what will happen with wood and iron. Okay, now here it is very easy to note that 0.68 is smaller than 1, right? Therefore, the relative density of wood is smaller than 1. Therefore, we can say that wood will float in water. We already know that by our observations, and now we have verified it with the mathematical support, right? And with the idea of relative density. Acha, here relative density of iron is greater than 1, and therefore we know that iron will sink in water. Iron will sink in water. So wood will float in water and iron will sink in water. Okay, so this we know, this is very evident, and the idea, the concept of behind relative density and sinking and floating object becomes crystal clear from here. Okay, so I hope all of you have understood what is relative density. Relative density is density of any substance upon density of water, both being in the same units, right? Then you find a number which is relative density, and relative density has no units. It is only a pure number, right? So this number, if greater than 1, object will sink in water. If number is smaller than 1, then object will float in water. That is the whole idea behind relative density and sinking and floating objects. Okay, so that's what they have written over here. Okay. Next, we are going to study about some topics which are, you can say, practical applications of relative density. Practical applications of relative density. The change in density of seawater with temperature due to mixing of fresh water from rivers has serious effects on shipping. When a ship loaded to maximum capacity and enters a seaport close to a river, it is likely to submerge more in it and may sink. Even the seawater at different locations has different densities depending upon the geographic locations, which can be serious threat to shipping. For safety considerations, all the ships have marking on their hull to show the level up to which they should be submerged in the particular sea or river. These markings are known as plimsoll lines. So, seawater has maximum density because there is a lot of salt dissolved in it. The density of seawater is more than the density of river water or pure water or sweet water, because of the dissolved salts. And that's why the ships, they do not submerge more, because the density of water is more. So it will not allow the ship to submerge more even if it is fully loaded. But these ships which are designed to sail in seawater, when they enter river water from sea water, they submerge more because the density of river water is less than sea water. So there is always a chance that they will sink if they are fully loaded. So plimsoll lines are marked around the hull of ships to indicate the level to which ships should be submerged in seawater at some particular location. If the ship is not loaded up to the recommended level, it is likely to sink or overturn in a rough sea. So I will show you what a plimsoll line is. Let me Google search and find some pictures of plimsoll lines. Okay, let's see uh, this picture. Okay, so I hope you can see this picture. Now, if you see a real ship, you will see markings like this on the hull of the ships. This is the hull of the ships. Okay. Now, this these markings, they show that up to what level will the ship be submerged in certain type of water, whether it is tropical freshwater load line, tropical freshwater load line, which is TF, that is the top marking over here. Okay, whether it is freshwater load line, which is just below the tropical freshwater, tropical zones load line, summer load line, winter North Atlantic load line. So in different regions of Earth, there are different levels up to which the ship will be submerged in water. You don't have to remember all this. This is just for your general knowledge and information. I'm sharing this with you. So, if a ship goes from one region to another region in water, it might enter from seawater to freshwater or freshwater to seawater or from one region of world to another region through waterway. But since all the waters of the world don't have same density, like Dead Sea, which is in Israel, Dead Sea has the maximum density because it has got maximum amount of salt dissolved in it. There are no live creatures, fish, aquatic plants, animals, nothing in Dead Sea. That's why it is known as Dead Sea. And you can actually float in Dead Sea. You can never sink because it has very high density. So if some ship has to enter Dead Sea, then you can imagine how will it float. It will actually, the level of that ship, the level of water when that ship enters Dead Sea would be somewhere over here. And then just imagine if the water is just over here, most of the part of the ship is above the level of water, and that may make it topple or overturn due to rough winds or rough sea. So that is in that case you need to load the ship more so that it can submerge more. So these kind of precautions has to be taken in order to keep the ship safe and floating above the surface of water when it enters from one region to another. And plimsoll line helps us understand how much the ship is sinking or floating above the level of water. And the direct application of this plimsoll line comes from the concept of relative density, right? So that's you can say practical application of relative density. Okay, one more important thing you should know: the whales can sink or rise in water at their will, and also the submarines. Okay, let's talk about whales first. Whales have a special organ called swim bladder. In order to decrease the density, they fill the bladder with air and thus they come to the surface of water easily. But to dive into the sea, they empty the bladder and this increases the density and they sink easily. So whales have this kind of natural mechanism in order to float on the surface of water or to sink deep inside the sea, which is the swim bladder. Submarines, on the other hand, which are man-made things, submarines, they have this ballast tanks. So ballast tanks are special tanks which are attached with the submarines. If a submarine want to rise and come to the surface of water, it fills the ballast tanks with airs. So it is connected with pump. All the water from that ballast tank is removed from with the help of pump, and air is filled in it. And as you fill the air in it, its density decreases and it rises above the surface of the water. Now, if it wants to go inside again, it will fill the ballast tanks with water. So that doors of ballast tanks will open and the water will fill in. The density of the submarine will increase and it will go down. So this is one important thing you should know. How the density changes in whales and submarines and these things allow them to rise up to the level of water and then again go inside whenever they want. Okay, one more important thing, which is the practical application of relative density, and to understand relative density in, you can say to a greater extent, you should always ask this question or find the answer to this question: why does an iron needle sink in water, but not an iron ship? Iron needle is compact. Its density is 7.6 gram per centimeter cube, greater than the density of water. The density of iron needle is more than 1 gram per centimeter cube and therefore it sinks in water. However, the iron ship is constructed in such a way that it is mostly hollow from within. It is mostly hollow. Do an experiment. Take a steel bowl from your kitchen and put it in the bucket of water and see what happens. Although it is steel, but it will float on water. Why? Why does it float on water? Because it is hollow from within. The shape of that bowl, since it has more air in it, most of the iron bowl is filled with air. It allows it to float on water. The same is the case with iron ship. Iron ship is hollow from within, although it is made up of iron from outside, but from inside it is hollow. So the volume of iron ship becomes very large as compared to its mass, and hence its densities decreases and becomes less than 1 gram per centimeter cube, and the density of iron ship is less than 1, hence it floats on water. So this is the scientific reasons why iron ships float on water but not an iron needle. Then we have to compare the densities in three states of matter. Now it is very easy to compare. Let me give you a pictorial idea about densities of substances in three states. Why don't we go to the first part? Yes, this part. And here, if we understand the three states of matter, and I will draw one more box over here and draw the particles which are close enough but not tightly packed. Okay. Okay, so let us consider this is solid, this is a gas, and this is liquid. Can you tell me which one has the greatest density just by looking at the arrangement of particles? Yes, now you can easily say, since more mass is packed in a particular volume in any given solid, hence solid has maximum density. density of solid, density of solid is maximum. So this is a general information, okay, not accurate, because wood is also solid but it has less density, okay, but generally solid has the greatest density. Then comes liquid. Since liquid has particles close but not close enough like solid, so the mass per unit volume of liquid is less than solid. So after density of solid comes the density of liquids. Okay, after density of liquid, the least density is of gases, because the particles are very far apart. So density of gases comes at the last. Okay, so greatest density is of solid, then of liquids, and then of gases. This is how we can compare the density of substances on the basis of the states of matter. Understand one more fact. The density of ice is less than that of water, which is an exceptional case. Ice is a solid, water is a liquid. Still, ice has less density than water. Also, wood. The density of ice, water, and steam are 0.917 gram per centimeter cube. This is the density of ice. 1 gram per centimeter cube. This is the density of water. And 0.00057, which is the density of steam, which is a gas. Understandable. Okay. So we understood the concept of density in different aspects in this particular chapter, also their practical implications: land breeze, sea breeze, plimsoll lines, whales, submarines. Then how to measure density, that also we studied. What is density? What is the SI unit of density? How to find density? What is the concept behind density? Everything we studied in this chapter. So if anyone asks you any questions regarding density now, I think you should have no issues answering it. Okay, now I will just discuss briefly some numerical problems which are shown over here, some solved examples, so that you understand that you know how to solve these numerical problems from your exercise. Today we are finishing this chapter, and after this I'll be doing math for your upcoming exams. So this chapter will be over, and the exercise will be given as final assignment, final homework for this chapter. Okay, so let's first discuss the numericals. So a piece of lead weighs 232 grams. What is 232 grams? It is the mass. Okay. When they say weighs or weight and mass, for now is to be considered as same. Afterwards, we'll understand what is the difference between mass and weight. But right now, they are the same. So mass of lead is 232 grams, and it has volume of 20 centimeter cube. Volume is 20 centimeter cube. So we have mass, we have volume. Find the density. So density is mass upon volume. See, mass is in grams, that is the CGS unit of mass. Volume is in centimeter cube, which is the CGS unit of volume. So 232 grams upon 20 centimeter cube, if you divide, you get 11.6. But what will be the unit of density of lead? Gram per centimeter cube. Since both mass and volumes were in CGS units, the density will also have the CGS unit. Very simple. Let's go to the next question. 5 liters of alcohol. Okay, 5 liters of alcohol. This is volume of alcohol. 5 liter. Okay, they have converted in centimeter cube. Always remember, I'll give you one relationship. 1 liter is equal to 1000 centimeter cube. Okay, which is also equal to 1000 ml, milliliter. So we can say that 1 milliliter is equal to 1 centimeter cube. Okay, next time if this relation is in front of you, like if some question has been asked and they are mentioning liter or milliliter, you should be able to convert it into centimeter cube easily. 5 liters of alcohol is a mass of 4 kg. So mass is 4 kg. See, they have quickly converted this mass into grams. Why? Because volume is also converted into centimeter cube. So we want to keep all the units in CGS system so that the density comes out to be in proper CGS or SI system. Okay, so we convert this mass 4 kg into grams. Next is density of alcohol. We have to find the density of alcohol. So density of alcohol D is equal to mass upon volume, mass per unit volume. What is the mass? 4000 grams. What is the volume? 5000 centimeter cube. So density of alcohol will be 4000 upon 5000, which is 0.8 gram per centimeter cube. Okay, now they have also asked us to find the density of alcohol in kg per meter cube. Now you should understand, I have taught you this earlier, to convert from gram per centimeter cube to kg per meter cube. What you should do? You should multiply by 1000. So here I've got 0.8. I will multiply 0.8 by 1000 and I will get 800 kg per meter cube. Is that the answer? Yes, it is. Easy. Next, always in in these kind of numericals, you should first read the numericals and then first list what is given and what has to be found out, then apply appropriate formula, check the units before applying the formula and put the values, get the answer. Simple. Find the mass of 555 centimeter cube of iron. Okay, so we have got 555 centimeter cube of iron, that is volume of iron, in kg. Find the mass in kg. Okay, so mass has to be found in kg when the density of iron is 7.6 gram per centimeter cube. Okay, so density is in gram per centimeter cube, volume is in centimeter cube. First let's find the mass in grams. So mass is, see, density is mass upon volume, so mass is equal to density multiplied by volume. Okay, so density 7.6 gram per centimeter cube, volume 555 centimeter cube. This centimeter cube and this centimeter cube will cut. You get 4218 grams. To convert from gram to kilogram, what you will do? You will divide by 1000. Gram to kilogram, divide by 1000. Remember that. I hope you already know that. So 4218 divided by 1000 is 4.218 kilograms. Easy? Yes.